thanks so much for taking the time to join us today for the episode of Scaling Robotics. Can you please introduce yourself?
Sure. Excited to be here. So my name is Amit Moran. I'm CTO at 𝐓𝐈𝐌𝐄𝐒, where we build and ship robots for construction. Before that, I co-founded Indoor Robotics for about 7 years, where we did autonomous indoor drones for security and safety checks. Before that, worked for a different robotics company for personal assistant robotics, and worked for Intel RealSense doing 3D vision, also for robotics. So yeah, my background is software, perception, and robotics autonomy.
Looking back, can you tell us a bit about the fleets that you've helped scale across Civ and indoor robotics? Be awesome to hear any stats about the robots that you guys had, the deployments, the customers that you worked with.
Yeah, absolutely. At Indoor Robotics, again, we did indoor autonomous drones. Those we worked anything from prototyping to actually deploying, dozens of those in different settings. We did warehouses, data centers, office buildings. So very, very diverse. All indoors, all operated after hours, basically replacing and augmenting guards. So it has a very specific use case to be fully autonomous from day one, since no one were supposed to interact with it. At Civ, we are building more collaborative robots for construction workers, very focused on solar construction, but we're doing also other kind of infrastructure projects. Those robots are deployed with humans in very harsh conditions. Very different kind of approaches, I would say, or they're very different use cases using autonomy to solve manual tasks. Yeah, and I would say that the most important things when we are actually doing and scaling robots from going from just a few to thousands and hundreds is repeatability, and I guess we'll talk about it a bit during this conversation. But how we can make something repeatable and the cost around that.
That's a great segue. I think, something I've always appreciated from you is how pragmatic you are, like you said, about repeatability, scalability. As a CTO now at Civ, what are those few core things that you're focused on to make sure the fleet can scale?
Yeah, absolutely. It's true for Civ and it's true for Indoor and for other companies that I'm interacting with. I think that there are a few things. One is ease of deployment, the time it takes actually to deploy, and how much of human intervention one needs to do. What we would like to get at any kind of, I would say any robotics company, is to be able to ship your product to the customer and they open it, press a button, and they do everything themselves. And this is what we are working on all the time. It's hard to do it from day one, but needs to be somewhere there, and you need to develop your robots and your devices in such a way that it can get there. So if I get to the point that interaction is minimal and it takes about 15 minutes to set up a robot, no, I succeeded. The second thing is about ability to debug, to understand what's going on remotely, because eventually you don't want your people to be there or support it as much. So saving data, being able to be proactive in some cases, so you get alerts if something goes wrong. And if something goes wrong, if it is by alert or if a customer calls and there is an issue, very fast to be able to understand what happened and have this data available for the support team so you can understand what happened and give a support if it's to fix or to sometimes replace a robot if there is an issue with the hardware.
I totally hear you on the kind of ease of deployment. I think on one end of the spectrum, I think about whenever I open the box that my iPhone comes in. It's this beautiful packaging. It's this really easy way to set up. On the other end, you have system integrators who are spending weeks on site making sure some robot works in a system. How do you think about moving your team incrementally towards that dream state? Obviously, you have to still ship robots, even if you don't have the perfect, I guess deployment workflow. But you have a goal that you want to get there. How do you balance those two things? What are those things that you're thinking about?
No, it depends. In different stages of a company, when I created indoor robotics, when we had the first few robots out there, and it's very different from when you come up at the end or a few years later on where you want to be. The most important thing is to ship. First thing, to ship products, to have it at the customer hands, to get the feedback, to do money actually, to make it to make something that is real and not just stories for investors. Um, um, but you need to do it from the beginning in this thinking how you will make it such that it will be faster, cleaner, smoother for the team that actually deploy it, and eventually for hopefully a customer can do it themselves. It's not always possible, but you want it to be that very short training is sufficient to deploy and to use such a robot.
Let's talk about some of those decisions that you make, those trade-offs you make from the beginning to the later stages. Starting with hardware, what are some of those early hardware decisions, let's say you made, that turned out to be very sticky, much harder to change than expected? Some of those assumptions that you made with just a few robots that kind of broke when you had 50 robots in the fleet.
At Indo, we had drones. Drones have a lot of constraints from weight, from power. So you need to tightly integrate things. At the moment you start tightly integrating hardware, it's very hard to change them. And I think that it's true also for bigger robots like what we do at 𝐓𝐈. The most important thing is to try to make it modular. So anything that we didn't think modular, it's sticky. That's it. You need to keep it. So if you tightly integrated your on your PCB a compute, can be an STM, can be whatever. That's it. You need to continue to use it, and you need to think about supply chains and how to get there. So at the beginning of the life of the robot, the life cycle of the robot, you want it to be as modular as possible, so you can actually do those changes very, very fast. If that something doesn't work, you can replace it and change and try something else. And even something malfunction, you can just change only that specific part. When you start scaling, it starts to be expensive, those things. So then you need to finalize your design, marry with it. And at the moment, it's there for a long time. It's true for sensors and it's true for compute. So hardware design is always difficult because it takes time to change. But it's true also for software, by the way. We did some decisions in the beginning that were very good in one hand and very bad in the other hand. And if you don't take the time to design the things correctly, even in software, you get stuck with it. We were stuck with I know we use ROS, so we got stuck with some ROS topics and names that were totally understandable for anyone outside of the team. All kind of mechanisms that made sense for quick and dirty, but then we get stuck. So now we are building some new mechanisms here at 𝐓𝐈, and we all the time thinking that infrastructure software needs to be done right from the beginning. Small features, it's okay if you are doing quick and dirty because you want to experiment, but anything which is infrastructure level, it's like hardware. You're going to be stuck with it for a long time, so you need to do it correct.
It seems like you're saying some parts of the stack are stickier than others, but in general, want to design with modularity in mind. Uh, on the second part about modularity, are there any things that you do tactically within the engineering team to emphasize the importance of this, to bake this into how you guys are designing hardware or even software?
Again, it's all about reliability and uh, freedom of operation, if you will. So what we do, there are two kind of things. From software side, we try basically to say if it is a work of infrastructure work, for example, connectivity to the cloud, how we can actually upload data, how we manage the health of the robot, um, how we are building the software from interfaces. Those stuff needs to take a longer design review process. In the other case, we still want to be very fast to product, and the velocity of development is important. So other stuff, we have different standards. It's okay to have different standards in a startup when you want to get fast to products to be able to experiment new features. So that's absolutely okay. So those standards can be different. And it's true also for hardware. But if there are pieces of hardware that are easier to interchange, then we are easy for us to make those changes. So anything which is regards to how the robot is built and how you can actually connect an interface between components, this is actually important to take time and design it correctly. Afterwards, at the moment you have a right design that is modular. So in our case, for example, Sieve, we value efficiency over um, over design, over something which looks nice. And I think that this is extremely important for our customers to be able to use something and to even fix it in the site. We have a very simple electricity block kind of that you on top of our hardware, top of our robots that can easily be open and fix something inside. So it's not the most small, nice looking box. It's actually bigger than what we need, but it's easy um, to interchange or to fix anything that is needed in the field.
That makes a lot of sense. Like thinking about from your customer's perspective, the things that they value, and then making sure that's how you guys design hardware and software to match, those needs and solve their problems. I love that. Earlier in this conversation, we talked a bit about autonomy. How do you decide, what level of autonomy is appropriate for a product once you're actually, in the real world, doing things that are in production? It's easy to make autonomous demos in labs, but as you said, reliability is super important for you guys. So how do you make those trade-offs and what do you aim towards?
I think that the most important thing is to really model the problem that you're trying to solve, what is required to do and what is not, what is absolutely must and what is not. It's true when a bit of side note, when we prioritize tasks, we don't have a medium priority. It either needs to be there or it's okay if it's not going to be. It's just nice to have putting something in medium, just making sure that everything will be in medium. Everything is okay. No, it or needs to be there or not. So it's the same for the problem you're trying to solve at the customer side. It's either a feature or a problem that you need to solve, or it's a nice to have. And this is where you basically put the line. What needs to be there, what must have, is where autonomy needs to be. If you must avoid obstacles, then yes, you need the sensors to be there. If you must avoid obstacles from a certain distance, you need to choose the right sensors. Don't say it's nice to have it that it will detect obstacles all around 360. If it's nice to have, it's not important. So this is the right level of autonomy. It's what must be in the product so it will solve the problem.
Once you've designed this autonomy, you're rolling it out. Um, how do you ensure the reliability aspect? Are there any fallbacks or fail-safes that happen when autonomy fails, when you're dealing with some really tough environments? Uh, how do you think about that, especially at scale, once you're deploying to customer sites?
Yeah, that's extremely important for early deployment as well as for scaling up. Just an anecdote at Indo Robotics, we had the self-flying robots inside facilities, and really at the really beginning, we had some sensor failing, and the robots start flying all over and and crashing things. It was really in the beginning, and we managed to stop it. And kind of the learning from that was that you need to fail gracefully. Fail gracefully is really important. The robot needs to understand its own situation, its hardware, its sensors, its expected algorithm outputs. And if something goes wrong, it needs to go to a safe state. And I think I'm not saying that here anything new for a lot of people, but this is extremely important. Even if you do toy robots, collaborative robots that we do now, or fully autonomous robots that did before. Um, so fail gracefully, understand what's going on. In case of drones, the most safe situation is to land, and you need to be able to land also safely, not just to crash on the ground. And it's true also for the collaborate robot. If the sensor, if a motor or something goes wrong, the robot needs to be able to know that and to take action. The second thing is um, is to be able to fix things as they go. So I think it's about like a self-healing system in a way that the robot understands there is an issue with a certain sensor, puts itself in a very safe situation, and then it can, for example, restart the sensor or restart the algorithm, restart itself in some situations, or just say I need help remotely, and then remotely, you can get help. Then it depends really if you have connectivity or not, but the whole support system is part of that, how you can actually fix an issue at a robot remotely. I think it's really important, again, from the beginning to think about that and to be able to develop your robots and your devices to support such situation.
I love the self-healing point. I think that'd probably save customers and you guys as a robotics company a lot of headache if the robot can, fix some things itself. And yeah, like you said, you don't want your robot application to crash and the drone to just fall out of the sky. It's probably not the thing that you want.
And eventually, I mean, from at least from my experience, it doesn't matter how expensive the hardware is. Eventually, it will fail. Many times, turn it off and on again, it just works. Um, so you need to design your system that you can actually turn off and on, basically restart specific subsystems. It can be just automatic or remotely. Uh, I think this is extremely important because eventually something will fail, even if it is industrial grade. And then you can either just wait for a support, agent to do the same, or you can have the system do it by itself and say, okay, I'm ready to start again. Obviously, you need to make sure that it's not happening all the time. You need to have some kind of counter, and understanding that if it's a repeatable issue, then you need to probably change the hardware.
It sounds like with, this kind of, setup, uh I don't know if observability is the right word, but a lot of really good logging and introspection to be able to understand how are each of my services faring on my robot, understanding the subsystems, the health of the entire system. Uh, is that the kind of infrastructure you're talking about to say, hey, we need to set that up early, we need to make sure that's in place because it's important downstream?
Yes, absolutely. So logging, um, telemetry data, um, ROS bags, if you have. I can tell you a bit about that, what we are doing indeed. But generally, just to answer your question, yes, to have the ability to understand what's going on with your system and know what I said in the beginning, to be able to debug an issue effectively. Yes, you need the observability part of the robots and alerts set up. Um, just an anecdote about the ROS bags that uh, at Indoor, we had a mission-based setup. So every time a drone used to leave for a mission, it used to be a few minutes and come back. We used to record all those ROS bags as a separate bags. And And we didn't know why we're doing all that. I mean, we knew why, but a lot of times there were a lot of bags were laying around in S3 waiting for someone to do with it something. We had eventually we did two things. First, we had a system that constantly ran every day, went through all those bags and alert if there is an issue with, for example, with the control system. You know, if it sees that there is a lot of the integrator parameter becomes higher than usual, or there is any other issue with the sensors, you get alerts. And another thing is that we, at some point, we wanted to change, the navigation algorithm, and it's tricky, you know, how to the localization, you know, how you know if it's going to work. And we have so many different environments. There is a limited number of tests environments that we can do, even in simulation. And it was extremely powerful that we can run our algorithms with the sensor data at all of our actual customer sites and see how it will behave on those sites before we actually releasing the new firmware, the new version. It was so powerful that at the moment we deploy it, we know that it will work well. So this kind of thing is extremely important, I would say, and we do it also now in Sieve, you know, saving the data. So one, you'll be able to replay it and understand if something happened. Second, we can um, analyze and get alerts. And third, proactively use this data to develop your next algorithm and test them before you even deploy them. Um,
I think that's a great anecdote, but actually thinking about data collection, the trade-offs between the cost of storing all this really, high fidelity data that takes up a lot of space. But on the flip side, we're in robotics, we're generally starved of data, and this data is pretty useful, like you showed us, in the future. How did you make those trade-offs? What data ended up being super important, super valuable? Were there, things that you guys did, any strategies there?
yeah, it's a very hard question. I believe, yet again, I believe that the more data we can save, it's the better. We can obviously put some policies in place that after X amount of time, it will delete the old data. So I think again, putting those policies in place sometimes can help, uh, only to save some of your some money. Eventually, again, the more data we save, it's the better. If you have to make a decision, uh, you start prioritizing by more important data, for example, around errors. So if you have a health monitoring system, like I hope everyone has, you can understand when things are going into a warning state or an error state. So you try to save the data before and after, so it can help you to just to debug. But yet again, the more data you have, you can actually do more stuff later on. So for me to say what is more important than other than saying, you know, prioritize by debugging. But uh, if you can have more data, you should have it.
We've talked a little bit about the technology, the stack that it actually takes, and the hardware and software to deliver a robot into production. Now let's flip on to the business hat, the business side. Um, at scale, your BOM cost, your margin, those pricing, all of those things become much more real constraints. When those enter the equation, how does that change the way you shape the technical requirements for the team?
So I think, you know, scaling is part of your vision when you're building a product. The same as you need to take it in consideration when you're designing your software and your hardware from the beginning and your deployment and your support. Everything needs to be taken in consideration from day one. The same as the hardware cost and BOM. Um, it's just part of the product. It's not part of the problem, it's part of the solution. And um, I don't think is right. A lot of people would say that the good approach to develop something is just to, take whatever, even if it's extremely expensive or, complex to integrate. That's okay. We'll figure it out another time. It's dangerous. It's very dangerous because you can get kind of married to those solutions. We talked about, before how you can do it. I mean, if you build your algorithm on um, the most expensive LiDAR or the most expensive NVIDIA, and you have algorithm that works, and then you say, okay, but later on I will fix it. Later on will never come, and your product will be so expensive that you have to either sell it for so much money or sell it in a deficit and have your investors basically sponsor the product. Um, so it's okay to say that you want to spend a bit more money in the beginning. But those stuff needs to be taken in consideration from the beginning. You should have a target bomb um, and a very good plan how you are going afterwards to reduce it if you exceed it.
It sounds like from day zero, we have this goal of what we want this bomb to be at some scale, and we have to be realistic about how far down we can drive it as things go on. We can't just magically snap our fingers and cut 30% one day when we wake up.
Yeah, and many times it's not happening that fast because scale, especially in hardware, um, scale takes time. Um, Also, it's not like software that you can spend a lot of money and then replication becomes very, very cheap, practically zero. In hardware, there is always a cost for BOM, for support, for deployment, for physical things happening in the world. So you have to take it from day one. It needs to be part of the design process, and don't think that one day you will solve it. At Indoor, from day one, we had the target bomb. It was very, very difficult to create full autonomy with this kind of bomb, and um, we got to it, but only because we said that from the beginning we're not going to put super expensive sensors. We had to find a way to invent a way to do things from day one. In Sieve, it's the same. We have very strict pricing policy, so we can actually provide value to our customers. If it's going to be too expensive, we won't be able to provide this value for our customers and for our investors as well. We're not going to do something that will be in deficit. So doing it from the beginning, I think it's really important.
I think support is an interesting one. Like you said, all hardware products usually need support because they're in the physical world interacting with things. Are there any ways that you design the system specifically to uh, address that fact? You talked about some of like the observability or fleet health. Do you connect those with some of your support systems? How do you make sure there's like a really tight loop there?
Yeah, it's a great question, and absolutely. I mean, the observability is one thing. Another thing is alerts, getting alerts of what's going on to directly to the support team, so to be proactive. We use some systems. There is a company called Robotics that we're working with that they're helping us to look at our data and create alerts also around what's going on, so our operation team could be proactive. Remote access is possible. Sometimes it's not. It's impossible to have remote access to some robots because of connectivity or because of customer constraints and requirements. But if it's possible, it's great to have a secure remote access so you can actually support it. And if you don't have a remote support, have the ability to update the software um, remotely or not, but update the software in an easy way and simple way. So if you have a need to provide a fix or even just to provide a new version that has a more logging, for example, you can actually easily deploy it at a specific customer site and to get this data. So fine tune control over the versions is extremely important as well.
Makes total sense. You talked about Roboto. Great guys. Love the team there. But in general, with tools like Roboto or other tools that you might be using, how do you decide what to build versus buy? Any principles there that are worthwhile for other folks to hear about, and yeah, would love to just hear what the framework looks like when you make those decisions.
At Indoor, I was all about doing everything myself. Um, Everything seems like a core important thing that we need to develop, and it was anything from the hardware design. We created our own drone, our own docking station, our own um process. Everything was kind of we did our own. It costed a lot of money. It and eventually the hardest part about those stuff is that you need to maintain them. It's not just about creating them. Creating is easy, it's fun. Then to maintain them, it starts to be difficult. Um, so my learning there was don't. If you don't have to, buy it. It's easy to create, it's hard to maintain. So if you can buy a hardware component or a software service, usually at the scales of most robotic startups, it's better to do so. It will be cheaper and more reliable. There will be a bunch of people actually working on this, and they're going to make it work well. If you're going to do it yourself, it will be more expensive. Once you get to a very large number of robots and the company grows to something very, very significant, you can think of how you can start taking things inside and do and reduce complexity or reduce cost by doing so. Anything which is not core, I would buy. My
Love that. Uh, pretty principled way to follow it there. Awesome, Amit. I think we've had a great conversation. So many different anecdotes and learnings for folks who are also building and scaling fleets. To leave us off, is there any advice that you'd like to give to other founders or engineers who are building and scaling robots?
design for scale from the beginning, but ship fast. The most important thing is to get to the customers as fast as possible to get the feedback and understand you're not doing something that is and not needed. Yeah.
Love it. Design for scale, but ship fast. And then also, any shout outs you'd like to make? Are you guys hiring? Any calls to action? Feel free.
Yeah, we are hiring a bunch of roles, about engineering, but not only. I would love to have people reach out. Um, yeah, and if you're a Bay Area founder, we also have a Bay Area network for founders in robotics. It's called Bay Area Robotics Network. So we can share things like that, talk about scaling our businesses and help. So if you're doing something like that, you should be part of our meetups. We have beers and pizza.
Yes, we do. Barn, as people call it, is a great time, and also, yeah, Civ is a fantastic company, based in SF. I'll link their hiring in the description. Please check them out. Yeah, Amit, thanks again for taking the time to share your wisdom. This was fantastic, and we'll see you later.